Hello students, I can't put any sort of an introduction on this video because my keyboard on my computer stopped working a few minutes ago. So at least I have my trusty tablet, so I'll be able to do this lesson. I know you're happy to hear that. Happy Friday. This is lesson 3, unit 3, lesson 3, and this is just graphing polynomials. And this lesson is really not any notes, it's just me working through some examples with you. So there are 4 examples in this set of notes. It covers pages 6 and 7, and then if you will notice, lessons 4 is pages 8 and 9, and then you actually have a quiz review in your set of notes. That is pages 10 through 13. We're going to be working on those next week, but if you wanted to get a head start on that, you could. So just as a reminder, you're going to have a quiz on lessons 1 through 4 next Wednesday. We'll be doing the review on Tuesday, and it will go through tomorrow, not tomorrow's lesson, sorry, Monday's lesson. Okay, so a lot of these key features we have talked about before. We've looked at, the A value, overall degree, and behavior, zeros and multiplicities. We looked at in the last lesson, what happens at those zeros, the y-intercept, intervals of increase and decrease, domain and range. So we've looked at all of those. The only things we haven't looked at are local maximum and local minimum. And you can probably figure out by just looking at those terms what they mean. You know what a maximum and a minimum are. And in this particular graph, you can see that there really isn't a maximum or a minimum. But when we talk about local max and local min, we're talking about any point that it kind of reaches a pinnacle, I guess you could say. It reaches a point and then it turns. Okay, so this would be like a turning point. So the local maximum is going to be up here, local minimum is going to be down here. So any turning point like that in a graph would be a local max or a local min. So let's go through this first graph together. So A value, they're not asking what the A value is, they're asking whether it's positive or negative. And we have the equation up here. We can see that that's positive. And remember, when an equation is in intercept form or factored form like this one is, what we need to do is add together the exponents to get the overall degree. If it were in standard form, it would start with an x cubed because it would be the x times the x times the x. And so it would start with the x cubed, but it's in intercept form or factored form, and so we're going to just add those exponents together. Overall degree is 3 here. The end behavior, if our A value is positive and our degree is odd, then what we know about the arrows is that they do this. And this is not something I talked specifically about in yesterday's lesson, but I have a way that I remember this. So let me just go over here and make a couple notes. So if the degree is even and the A value is positive, then the arrows do this. Okay. If the A value is negative and it's an even degree, they do this. Okay, if it's positive and odd, it's like this, and negative odd goes like this. Okay, so here's kind of how I remember this. This is like a 2 degree, and this is like I think of it as being an odd number, but I think of the number 1. Okay, so here's what I think of. It's weird, but this is how I remember it. Okay, so if it's an even degree, I think of the number 2, and I think of 2 arrows going the same direction. Okay, so it's like 2 people who are walking together in the same direction. And of course, the up direction is a positive direction. So this would be a positive A. And then this is 2 people walking in a negative direction. So this is a negative A. All right, so for this one, I know it's not really a 1 degree, but I think of a one person. And I think of one person walking in a positive direction. So the person starts down here and from left to right, and it ends up in a positive direction. So that's the positive. So this is odd positive, and this is odd negative. And I think about one person starting on the left and ending up going in a negative direction. So that's how I remember which ones of these work with which A value and which degree. Anyway, okay, so all of that aside, let's talk about the end behavior of this graph. Okay, so again, we are looking at the arrows, just the arrows. That's what's at the end, or that's what's heading toward the end of the graph. So on the left side, so let's do left side first. On the left side, X is moving to the left and y is moving in the downward direction, so this is negative, negative. Okay, so let's go ahead and do that. So we have x approaches negative infinity, and then you can say as, or I don't care, just do your arrows. Y approaches negative infinity. All right, on the right side, x is approaching positive infinity because it's going to the right, and then y is also approaching positive infinity. So positive, positive. All right, so they match, negative, negative, positive, positive, if the a value is positive and the degree is odd. Okay, zeros and multiplicities. Okay, so I'm looking for my roots or my zeros. Here they are right here. There are 3 of them. I have negative 1, 0, 2, 0, and 4, 0. Okay, what happens, Adam? All 3 of them pass. And if you remember from yesterday's lesson, a 1 exponent is a pass. So all 3 of these, and you can just put a P for all of them. Draw a little arrow. And all 3 of them pass. All right, the y-intercept is up here, and I didn't even tell you, I did this on Desmos. I went ahead and graphed it for you and put the screenshot here, so you don't have to do that. You could go over and just check my work, make sure I did it right. The y-intercept, I want to see an ordered pair here, not just an 8, but an ordered pair. Okay, so local max, what we're looking at is this point right here, and that is this, and sometimes I'll tell you to round these, but we're not going to round them here, and it is an ordered pair. My pen's messing up. Okay, local minimum is down here at the bottom, so that one is another ordered pair. Okay. Going to see if I can move this up a little bit. I don't know what it is about this tablet. Okay, oh no, I can't. We got to look at intervals of increase and decrease. Okay, so if you remember back, I don't remember when we were doing these. I think it was in Unit 1. We talked about intervals of increase and intervals of decrease. So this is where I want you to think about that roller coaster going uphill and downhill. So intervals of increase is where it goes uphill. So I'm going to highlight this. Let's do increase in yellow. All right, and there are 2 intervals of increase on this one. Going from left to right, I'm going uphill from here to here. Okay, that won't curve anyway. And then going from left to right again, this is downhill. So that's decrease. This is uphill, increase. Okay, so let's talk about what those levels are. Okay, or intervals, sorry. Okay, so this one right here go from left to right. It goes from negative infinity and it stops up here at 0.214. We're looking at x values. Now, on this one, I'm going to use parentheses. I'm looking at something. I'm looking at a key here, and it does use brackets, but at that point, it's neither increasing nor decreasing. So I'm going to argue that it would be a parentheses. I will question my colleagues and find out and let you know. All right, so there's another one. Use your little symbol there. The next one goes from 3.12. And this one goes to positive infinity. I have 1 interval of decrease on this graph, and it's from here to here. And again, I'm going to argue that it should be parentheses, so I'm going to use parentheses on mine. This one goes from 0.214 to 3.12. The pen doesn't want to work today. Domain, this one goes forever to the left and forever to the right. So domain, negative infinity to positive infinity. You see, it doesn't even want to draw a circle. And range is the same thing. because it goes forever in the downward direction and forever in the upward direction. Okay. Okay, in the interest of time, I've already done a part of this because I used up 10 minutes on my first problem. So a value is negative. Overall degree is 5. You add the 3 plus the 1 plus the 1. In behavior, I didn't finish it, but this is the left side. The left side, x goes toward negative infinity, and the right side, it goes toward positive infinity. So on the left side, y is going toward positive infinity. And on the right side, y values are decreasing, so they are going towards negative infinity. All right, at the x-intercepts, let's see. At the negative 3, 0, it passes. At the negative 2, 0, it passes. At the 1, 0, it actually curves. It's hard to see because this is kind of covering it. But this is a curve. It's a 3 exponent. Let's see, what else do we have? I did the local max and local min because there was one of each. I went ahead and did that. Intervals of increase. There are 2 intervals of decrease, and there's 1 interval of increase. I'm going to fill those in and come back. Okay, so because my pen is messing up and it's taking me so long to write stuff, I didn't want you to have to wait for that. So interval of increase, there's 1, and that's this teal kind of turned green in some places. So it's from negative 2.6 to negative 1. And then decrease comes from positive infinity. Oh, no, I'm wrong. I'm sorry. That's negative infinity because I'm thinking y values. So this is x values. Negative infinity here. And then it goes toward positive infinity, and that's because that's x values. So, all right, let's move on to the next one. Okay, so I'm gonna go through some of this stuff kind of fast. We have an x here. This is important. This is one of the factors. This is an exponent of 1, an exponent of 2, and another exponent of 1. A value is positive. The overall degree is 2 plus 1 plus 1, so it's 4. So this goes upward on both sides. So no matter, all this stuff happens in between, but at the ends it does this. Okay, so that's what we need to think about. Okay, I'm gonna do end behavior in a minute. Let's talk about zeros. They're easy to find. So this is one of my zeros. X equals 0 is one of them. If I go in order though, I've got negative 5, 0, negative 3, 0, and 0, 0. If you didn't have the graph here, you can still tell that from this equation, x equals 0, x plus 5 equals 0, x plus 3 equals 0. What happens, you can also still tell from the equation. So at negative 5, 0, I got a 2 exponent, that's a bounce. Negative 3, 0, I've got a 1 exponent, that's a pass. And at 0, a 1 exponent, that's also a pass. The y-intercept is at 0, 0. Oh, I didn't mean to go back to that one. There we are. Okay, so y-intercept 0, 0. Local max, there's 1 right here. Local minimum, there's 2 of them. There's one here because that's a turning point there. And then there's another turning point right here. So at negative 5, 0 and negative 1, negative 32. I went ahead and did the domain and range. Domain is all real numbers. The range starts down here at negative 32 and goes to positive infinity. Okay, let's see, what else do we have? We have in behavior. Let's do in behavior. Let's do, this is the left side of the graph. And then this is the right side. All right, so what is it doing on the left side? Y is approaching positive infinity. And on the right side, it's doing the same thing. Okay, what do we have left? Intervals of increase and decrease. Okay, I'm going to get my highlighter. Need to make this thinner. All right, so let's see. Going from left to right. Decreasing. Increasing, not going to draw there. Decreasing here. And then increasing, so I need to change the color there. So this is, oops, this is increase, and this is increase. Okay, let's figure out what they are. Increase. Those are the purple lines, and I made a mistake here and put negative 3. I should have put negative 5 because I just looked at that point incorrectly. And negative 1 to positive infinity. All right, and then decrease is the yellow. So this one comes from negative infinity to negative 5. This thing's driving me crazy. And then negative 3.75. And that one, did I do that right? Yeah, that's right. And that one goes to negative 1. Okay, I think that's it for this graph. Okay, so this is number 4. So this is the last one. And let me move this back up. There we go. I just went ahead and filled everything in. There are 2 local maximums and 1 local minimum. You've got your 3 zeros right here. And I went ahead and I put the exponents there too. And I also filled in here, this is a quartic polynomial. Intervals of increase, there's 1. No, that's not right. Oh, 2, I'm sorry, 2. So here, increase, decrease, increase, decrease. So there's 2 of each. And then domain and range are right there. Something I wanted to go back and do before I end the video is this is number 1. I wanted to go back and name these polynomials. So just by the degree. So this one's cubic. This pen's getting on my nerves. This one's quintic. And then we did number 4, and this one would be quartic. So if you want to add that in there. And the other thing I didn't mention is if you don't have a graph in front of you and you need to figure out what the y-intercept is, you just set all your x's equal to 0 and then solve for your y. And I haven't done that since Unit 1, but just in case you didn't have a graph in front of you and you had the equation and you needed to know what the y-intercept was. All right, I think that's it. Yep, we did that one. I haven't finished your mastery check at this point, but I wanted to tell you that what I'm going to do differently on your mastery check from now on, I think, because I know that some people really wanted to do better than they did yesterday, is on your mastery check, I'm going to make it so that you have to score at least a 90. So if you don't score at least a 90, which, you know, that way everybody gets to make an A because they will count as a grade. So if you don't score at least a 90, then it will prompt you to retake the test again. And they're so short that it's really not a problem. But what will happen is it will, because I can't set it up to where you can change your answer and it shows you if you're getting it right or wrong. So I want you to be able to either change or get it, or see if you're getting it right or wrong. And I would rather you see if you're getting it right or wrong. So then what it will do is if you don't get the 90, it will say you didn't score whatever the minimum is required or something like that. You need to retake it. So just look for that when you do your mastery check today, and I'll do that from now on. I think I'll just set a minimum grade of 90. I think that will be satisfactory.